All right, we're back. We are on slide 26, and we are looking at the male reproductive system kind of in total, right? The only thing there that isn't really part of the system is the bladder, but you have it there for reference, right? So we were talking about semen. We had talked about how you make the sperm cells, but we had said the sperm cells are completely helpless without either Sertoli cells or someone helping them, right? And so the seminal fluid is there for them. And so we have these other glands that are involved in producing the seminal fluid. We have the epididymis, the seminal vesicles, the prostate, and that little bulbourethral gland, which did its job kind of before the fact of getting the urethra ready prior to ejaculation, right? All right, so moving to slide number 27. You produce a whole lot of sperm cells with each ejaculation, when you're having sex. So you have 50 to 120 million of those babies for every milliliter. And I said when I used to breed horses, what they would do is they would artificially collect this from the horse, and then they would cut it because you don't need that much. You only need one to get a horse or to fertilize an egg. So they'd start out with a whole lot, and they'd give you a lower concentration, and that way they can make more money and produce more babies. So anyway, so you have a whole lot of sperm cells in there. 50 to 120 million per milliliter, and you have 2 to 5 milliliters in humans. How many is... I'd said that crypt orchid individual, they have less testosterone and a lower sperm count. If you're having fertility problems and you go to a reproductive specialist, they will analyze for this. And what they can find is if you only have 20 to 25 million sperm cells per milliliter, you're considered infertile. You're not likely to be successful. So when we talk about natural breeding of, within people, it takes a lot. It takes a lot of them because remember on the previous discussion in one of the previous videos, I said that only 1 to 100 will make it to the ovum all the way up there in the oviduct. Okay, so the sperm cells are mixed, are non-modal, actually, in the epididymis. You can imagine if they were swimming around in there, it'd just be crazy. So until they are mixed with the seminal fluid, they're just hanging out like any other cell, boring, not doing anything. So they can live, though, in for a number of weeks in the epididymis. But after ejaculation in the female reproductive tract, we say 3 days. I don't know that I believe that, but 2 to 3 days are how long they can survive there. Okay, slide 28. What is in this stuff? What is in this semen? So we have energy sources, right? We've got fructose, we've got the sperm cells themselves. Fructose, glycogen, clotting and anti-clotting factors, and prostaglandins. Okay, so the glycogen, so if we look at what is contributed by each of these glands, the epididymis is going to contribute glycogen. Now remember what glycogen is? It is a polysaccharide of glucose. So it's a source of glucose. And it's also where the sperm cells are stored. So they leave the epididymis with some glycogen, and they move to the area of the prostate. And at this point, you're going to pick up the secretions of the seminal vesicles and the prostate gland. The seminal vesicles are going to add the high level of pH, which is there to help neutralize the acidity in the female reproductive tract. You're also going to have fructose and prostaglandins added. Fructose is a sugar, right? The prostate gland is going to add citric acid, prostaglandins, clotting, and anti-clotting factors. When all this stuff is mixed together, the sperm cells come alive and they become motile. All right, so maybe you're wondering about a couple of things that I've mentioned here now. Maybe your mind is going, think, 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 think. What are prostaglandins? We had said that they have a local effect. And then you say, clotting, anti-clotting, what's that all about? Well, let's go to slide number 29. So what happens? So after the semen is deposited in the upper portions of the vagina, right up next to the cervix, it clots. Now, and after about 30 minutes, it unclots. In the meantime, those prostaglandins start doing their thing. So what did we say? Prostaglandins do a variety of things, and one of them is they cause contractions. Oh, darn it, I have one of these birds. Well, if I'd been thinking, I'd have brought my little bird out. You ever see those things? It's a little bird that you can get from like a tourist shop, and it dips its head in a glass of water, and then it goes doink, 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 and dips it again. And then it goes doink, 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 and dips it again. That's what the prostaglandins do. One of my colleagues used to, at this point in their lecture, say that the effect of the prostaglandins always reminded him of his grandmother. And he would get shock from his students, because after all, we're talking about reproduction here. Well, what it was is he said, yes, she had one of those birds, and he would talk about the bird. Well, what the prostaglandins are doing to the uterus, they're from the boy, they have their effect on the uterus, is they cause the uterus to start contracting and the cervix to start dipping down into that pool of semen and pulling it up into the uterus. And that's the bird. That's the bird thing I'm talking about. So the prostaglandins, so the clotting and anti-clotting factors are there to keep the semen high in the female reproductive tract until long enough for the bird to kick in, for the cervix to start contracting and dipping down into the pool of semen. Okay, so let me see what else I need to say. So for 15 to 30 minutes, you have it's clotted, then it's anti-clotted, and we say the prostaglandins stimulate peristaltic contractions of the female reproductive tract. That's what we're talking about with the cervix dipping down into the semen. Okay, one final slide. Slide 30, and it's talking about the testes. And I didn't really mention at this point in today's discussion, I didn't mention why the testes migrate down the inguinal canal with the aid of the gubernaculum to a position outside of the body. And the reason for that is that the sperm cells require a temperature lower than normal body temperature in order to mature. And so oftentimes, in one of my other classes, I talk about problems in conception, having babies. And we had talked about how about half the time it's the male and about half the time it's the female. And one of the things that if people are having problems having a baby, they tell the guy to change their underwear. Change the kind of underwear that they are going to be wearing. Because oftentimes, especially in young guys, you wear this brief type of an underwear. That's the one that kind of holds everything up close. And then later in life, sometimes it's advantageous to change to the ones that are kind of like a pair of shorts. Why do you do it? To keep the testes cooler. And sometimes that will solve the problem. So the testes are in the scrotum so that they can get away from the body because they need to be a couple of degrees cooler, 2 degrees centigrade, cooler than body temperature. Other ways, now blood, you might say, but there's blood, there's hot blood on its way down there to them. Well, you have something called the pampiniform plexus. It's a series of capillaries that are near the surface, and their job is to try and radiate some of that heat away so that when it gets to the testes, it doesn't cook the sperm cells, and it allows them to be at the proper temperature. We have two other muscles there. Now, sometimes, and this is really, it relates to humans because this is human anatomy, but if you think of animals, and if you're out there without any clothes on in summer, everything needs to be down pretty far. And then in winter, you don't want everything to freeze, right? So you can pull it up closer. Well, humans, we have the same ability. We have the cremaster muscles and the dartos muscles. And what do? They are there to pull the testes up closer to the body if it's too cold. All right, so this is the end of the recorded version of this lecture. We're going to talk a little bit more again about this same lecture Monday morning, bright and early. So I'll see you guys then. Take care. Bye now.